Hey guys, Cloud here, and today we will be covering something that has been much requested from me for the past, I think, year and a half, but I really haven't done it because there really wasn't a consistent method up until 1.18 came out, and then it was a matter of me going through the pain of updating it. But if you are here for the title, it is a shader selection method, which essentially lets you toggle or select different shaders based on input from a data pack. So this is one of the examples I've put together, which will be for download at the GitHub. But essentially the example here uses the multi-channel capability. It has two channels, the shader selector, and we have one which is flashlight on or off, and the other which is the battery level in the top left corner of the screen. So when I turn the flashlight on, the battery level will go down. I can turn the flashlight off at any time. It'll stop making the battery level go down. And then eventually when the battery level hits 0, my flashlight turns off. Now there are a couple of things to discuss in terms of efficiency and capabilities and potential issues with this pack. So let's just dig into all of the details, starting from the basics. So if you want to make a pack where you can select different shaders, you need to have some kind of input from the game. But what kind of input can you have? Well, according to some wikis, and you can test around yourself by going into each of these things known as core shaders and setting their colors to whatever, like red, just to see what's on the core shader. You can kind of deduce what is rendered on each core shader and what kind of things that you'll be able to detect. The common one to use is a glowing effect with different colors, but that's kind of limited in what you can do because there's a limited number of colors. So there are a lot of different options for going about this, but the one that I chose as probably the most non-invasive method and easiest to customize is the kind of item drop. Now, obviously you can experiment and figure out which one you like best, but the way that items work is there are some items in the game that are rendered on a different buffer than regular items, and they have transparency, so they're handled by a different core shader than a block of dirt, and those items are stained glass and some other transparent items. So what you can do is you can create a 3D model, and then the 3D model can just be a big cube, okay? So why didn't I release this pack before? Well, this is what it has to do with. Look at this cube. Notice something weird? Well, before they added the ability to mess with core shaders, you essentially had to work with a shaded version of the cube. So part of the problem that I had before was the frag color was not getting a constant value. So when you have a 3D model in the game, it's going to have some natural darkening. You see this item on the ground, see how each edge of the item has a different kind of shade because of the shadowing? Well, that's kind of like inherent in the game, but that is not inherent when you're messing with the core shader. So since we have core shaders, I am basically able to look for an item that has an alpha of 1 and an R of 1, and then set its alpha to just always be 1, okay? So I can basically interrupt this stuff because by default what the game does is it applies some fog logic to get that shadowing. It creates some color modulation and some fog. So I can basically bypass that color modulation and that fog for the specific items that I've generated as 3D models, okay? So then they will be 100% consistent what they are to the program shader. So inside the program shader, it's similar to what I've shown before. So when we go to post transparency, this another thing to note is that this only works with Fabulous. You have to have Fabulous on to do this shader selector. But I mainly just chose that because I want the depth buffer. But anyways, so this, I will go into how it works in a second, but you run the transparency shader as it is, and you make one little modification. If it is a red 1.0 item, that means that it's our special item, and we set the alpha to 0. So that basically makes these guys invisible on the ground, so you can seamlessly hide it besides the shadow. The only thing that's not hidden is the shadow. So without that, you literally can't see it. Okay, so that's how I basically hide our input selection. So how do we read what the input selection is and remember what the input selection is? Well, that's using some program shaders. Okay, so this is kind of complicated how it works, but essentially we have a 1x1 pixel buffer and a 1x1 pixel buffer copy. Okay, so at the very beginning of our pass, we copy whatever is on the input buffer onto the copy buffer. Okay, then we scan the image looking for a pixel to put on the buffer. Okay, and then we also pass our copied previous buffer. So then we can compare inside here the previous versus the new thing you're looking at. Okay, so let's go into scan. Inside scan, you can see here that it loads what the previous color detected was, and that's what it loads onto the output color by default. But if there's these special conditions, such as the item is close to them within 1 block or whatever 1.0 units is, and the color is exactly red, then we're going to change what that item color is based on this logic. And this is how I do the multi-channel. So if blue is 1.0, then update green. If green is 1.0, then update blue. If blue is 1.0, then update green. So this kind of lets you pick one channel or the other, and we'll go over how that works in code in Minecraft, so how you use the pack. So this kind of just updates the color on this buffer right here, and then down here at the bottom we run the draw text debug, which I did not make this. I will have a link to where this came from, but it's very old, but I've updated it slightly so that it works with the latest version. But this basically just renders this text in the top left for debugging purposes. And we'll go into what you need to do. Like, you just need to delete these two passes in order to get rid of it for your pack if you're done debugging. So then we run to the eval. So the scan and the eval are separate steps. The scan happens before the transparency step, and then the eval happens after. So eval is kind of like what you do based on what the value is, and there you just pass the copy sampler. Okay, so you just got to pass the buffer, essentially, the thing that you wrote to. So then after you pass that, then you pass it to just a final blit copy, which is a util blit copy. It's a special blit copy, and it just kind of copies whatever was there. So first we make a copy of what the previous sensed color input value is. Then we make a copy of that. Then if we see something change, then we update the original. And then we make logic based on the original. And finally, we output the logic processed frame. So then the next thing to look at is eval. So eval is where the logic happens, essentially. So this is where we kind of make our shader happen. So this is going to be where you actually do stuff. So inside this file, you can see that I essentially check the green channel and I check the blue channel. And then I also added overlay logic for overlays, but in this case, there is no overlay. But it's nice to have this blending here, which is the same as my previous video on shaders. So what we do is we set the color of the pixel you're currently at to whatever color it's supposed to be. Okay, and then we check the selected color green value. If the green value is greater than 0, if it's some in between, if it's some value that is not 255, essentially, then we're going to add that to the screen's color. And if the blue value is some value that's not 255, add that to the blue's value. So how do we get this working in game? So we basically just have to give ourselves white stained glass that is custom model data of 1, 3 digits, and 3 digits. Okay, the 3 digits, the first 3 are the G and the second 3 are the B. Okay, so if I want to give myself something that has a G of 069, I just do that, and you can see in the top left corner, red is 255, green is 69, blue is 255. Okay, and that'll just add the green. Then if I want to set the blue channel separately, I can do 1, 2, 3 and 255 on the green, and that'll keep the green at 69 and say 1, 2, 3. Now you can't do both because that would mean I have to create, I think, a couple million 3D model files. So it will just take whatever, it'll typically just take green precedent. So just make sure that if you want to set 2 channels, you have to use 2 separate commands. Now, this is where we discuss kind of like how accurate this thing is. So we have the give command, which works pretty good for it, but it's not perfect, and it makes a little pop sound. So you're better off using something like a summon command inside the player's face. So that's where the example pack goes into. So let me dig into how I added the shaders to my code and kind of got it working all together. So now we're basically going to go over how I built the example here. So essentially all I did was I go into this post and I added an extra aux target, which is the flashlight sampler. This is just the texture used for the flashlight overlay if you wanted to add an overlay. So I'll show you how I did that. So I basically add this line of code, which basically looks for a file named flashlight inside the effect folder. So you have to go into the Minecraft textures effect and add a file called flashlight. Okay, so this flashlight file is one that I built, or I put together specifically to work with the logic of the shader. So it's essentially the file size here, which is 408 width and 1205 height. So that has to be the same as this. So if I go into edit image size, you'll see it's the same. Okay, but notice how there are 5 different basically sheets here that we're going to be using. Okay, so we import that texture using this kind of aux target, and make sure you have commas for your list and you end without a comma. So then inside the eval, so that's literally all you have to do. So you mess with what extra info you need in the aux target. If you do need extra info, then you go into program, POI, eval.json. You add that here. So I added the flashlight sampler here. And then I also added this FOV uniform, which is used in the flashlight logic. So this kind of stuff, you have to kind of know how to use GLSL and what you're trying to do here. So then inside eval.fsh, I also have an eval VSH, which doesn't really do anything. And you can make it do stuff if you want to. But anyways, eval FSH has an added function for linearized depth, which basically calculates the distance. I added the sampler up here, flashlight sampler, and I added the uniform here, FOV. So then inside here, I changed the logic for the green and the blue channel, which is what you'll probably want to do as well. So I check if green is 254 out of 255, then we turn on the flashlight. If green is not that, then it will just default to whatever the pixel's supposed to be, which is if green is 255, then it will not have the flashlight on. So for the flashlight, this is the exact same code I used for my flashlight tutorial on how to do depth, on like the depth tutorial, how depth works. And you can see that. I'll put it in the description. I'll link a couple different of these tutorials in the description that go a little more in depth on how this works. But essentially, we just figure out how far away the pixel we're trying to draw is, and then increase its brightness based on the distance from the center of the screen, as well as how far away it is. Okay, and then we add that, we set the frag color to that. Okay, notice how I set the frag color. If you're doing something that's setting the frag color, you're gonna have to do this. You're gonna have to mess around with the logic of whether you add to frag color or set to frag color, because it's kind of complicated to get that working. So then inside the blue channel, then this is where the logic works for the batteries levels. So if the battery level is by default is 0, but this is inverse, so 0 means that you have full battery and 4 means you have nothing. So then you check if the blue channel is 254, then set it to 1. Else if it's 253, set it to 2. Else if it's 252, set it to 3. Else if it's 251, set it to 4. And the reason I did else ifs instead of a switch is just because I have these kind of like fractionals that I like to have here. And I could have done a switch, but I just went with an if else because it is a little bit easier for people to understand. So then we have overlay. So this is where you apply the overlay. So based on battery, I essentially just pick the y coordinate based on the battery. So the x coordinate is the x coordinate of the pixel, and then the y coordinate is based on the battery. So if you're on the battery level of full battery, then your y coordinate is just the y coordinate that you already had. If you're at the no battery, then it's going to be at the top corner of the bottom. So it just kind of transforms it essentially. And then finally, this kind of mixes whatever our overlay was with the RGB. Okay, so that's how we set up the shader pack. And then I obviously hit F3T and everything is running as expected. And I do /give 254, that turns the light on. 255, that turns the light off. Just like that. Okay, and then I do 254, that makes the battery 1. 253, 2, 251, and boom, just like that. Okay, so now we have to get into how I set up the data pack. So in the shader selection example, it has a function folder, and that's really all it uses. So this one, you have to mess around with what works best for you. So I just detect if the player right clicks a warped fungus on a stick and has some battery level, then you toggle the flashlight. So in the toggle the flashlight, it increments a score and then sets the score to 0. So these two commands essentially just implement the toggling. I could have done times -1, same difference. But then it runs shader load. So shader load basically runs logic based on this ssf.green scoreboard, and then it just plays a sound effect. So inside shader load, essentially it kills all of the original shader loading items, because this is something that, I mean, you could get rid of this. It depends if you're in single player or multiplayer, but it's safer to do this if you can. So it goes to the player, and if the score is 0, then it summons a item that is a white stained glass. Now, these are the important kind of settings that make this nice. So we're setting the flashlight value to 000, which would just turn it off because it's not 254. But the two important things is the age and making sure that there's a pickup delay so you don't pick it up. But the age is the important part. So the age is when it reaches 6,000, the item will despawn. So it's how many ticks this item will stay in the game. And the more ticks you give it, the more likely it will successfully apply the shader. It is fairly accurate, but it is also potential for it not to actually trigger. And that's where you have to kind of play around with the right values of age, or the right values for how far away you can detect the item and that kind of stuff. You'll have to play around with what works most efficiently. So I set this one's age to 90, which gives it 10 ticks. And I set this one's age to 85, so it gives it 5 ticks where this one is dead, because obviously it can't set 2 at the same time. And this is the same idea. You're just setting the blue channel based on the score. Okay, so then inside main, I'll have a once per second function that runs shader load. So that just kind of, because you have this problem of you don't know if the shader got applied, and somebody could hit F3T and it could unapply or go back to the default value. So basically every second I just reload whatever they're supposed to have. You can change this if you're to be like, when they trigger the flashlight, really make sure that the flashlight was on. And if you really make sure that the flashlight is on, then you're fine and you don't need to update it all the time. This is really just up to you. So if I right click, the flashlight goes on. If I right click, the flashlight goes off. But you can see there I right clicked and the flashlight didn't come on immediately. It took a second for it to come on. So that's where it's a little bit inaccurate, but I'm sure that there's different things you can do in terms of where you spawn the item. I just wanted to get this pack out there so you guys can mess around with it. Because personally, I'm not going to be using shader selectors at the moment, so I'm not going to find the best way to use this. I think the important part is the shader, and then it's up to you to make the selection work properly. Or maybe you want to make it use a different input, but at least you have the code for persistent shader choices. But anyways, that's it for this one. That's the pack. There you go. That's how I put together the example. And both of those will be available at the GitHub. So if you thought that was cool, leave a like. And let me know what you want to see next. Thanks for watching, and I'll see you next time. Peace.